Alright guys, welcome to section 1.4 of notes. Today we're going to be talking about the transformations of absolute value equation graphs. As you will notice, I'm not in class today, unfortunately. I am quarantined again until Tuesday, so I will be back on Tuesday, fingers crossed. But we're going to be learning virtually today. So I've got a little video for us, numbers document that we are going to be using for the activity that we're doing today. And then we'll finish up with a little bit of notes together in this video once you guys get that activity done. And then we'll have just our homework problems, homework check to work on and get that submitted to Canvas. Today's activity is pretty fun. I wish I could be there to do this with you guys, but we'll make the most of it. It'll still be fun. So let me explain to you how this is going to work. So I have this put into my Explain Everything app, so it's just the PDF version, so it doesn't look quite the same as yours. Yours is going to have little boxes under the parent graph, graph A, graph B, and graph C. And then there are a few different tabs with different names on them. And so what your job is to go onto what is Desmos.com, and you will plug in each of these equations. Okay? Once you've plugged in, for instance, the first one, you'll take a screenshot and you will hit the little camera logo and submit that picture into the Pages document, numbers document, whatever it is. But you'll have it right there. Same thing with graph A, B, and C. And then once you have all of the graphs in there, then you'll just go down here and you'll answer these questions. So they're just true or false questions. So the first one is graph A. So comparing graph A to the parent graph, which is just this top one, it's going to be the same one for each tab. But comparing graph A to that parent graph, did it shift up, down, right, left? Is it compressed or stretched? And did it flip? Okay, so pretty simple questions. If you get them right, they're going to turn green. If you got it wrong, they're going to turn red. So if you did get it wrong, make sure you go back and regraph it because that probably means you did it wrong. Okay? How to type these into Desmo? Pretty simple. You're literally just going to get on here and go to, this won't work, there we go, Desmos.com. Click go. Hit this graphing calculator icon. Okay. Okay, and here we have our graphing calculator. So how this is going to work is you're just going to type in the equation exactly how it is. You don't have to type in the f of x or y equals or whatever it is. Just type in everything after. So that parent graph, for instance, is just the absolute value of x. So I'm going to go down and I'm going to hit this little absolute value button. It's right here in the bottom left corner above ABC. It's like it says absolute value of A. So that's going to bring up these two bars. And now I'm just going to plug in X. And there it is. Screenshot it. Put that little image into the numbers doc. And then just answer the questions. So honestly, it shouldn't take you that long to do these because you're just typing them in exactly how they are. And each of them has a parent graph on it that's exactly the same. So you're going to use one of those pictures 4 different times. Okay? So go ahead and do that. Answer the true or false questions. You are more than welcome to work with a partner, if you please. You will have about 15 minutes. So I'm going to have these subs set a timer for 15 minutes while you guys do this. So go ahead and get going. Okay, so if you have made it to this point, that means that you have your numbers document filled in, or hopefully mostly filled in. Hopefully you got as far as you could on that. But we're going to go ahead and talk about it just for time's sake, so that way we get through everything we need to get through today and you guys still have a little bit of time left over. There will be a Zoom link at the end of class today for you to join, so make sure you look on Canvas to see what time it says that I will be on there, and then make sure that you join if you have a question. If you don't have a question, don't worry about hopping on there. But we'll start off here. We have our first tab, which was the A shift tab. Okay, so what we'll notice here is we have our parent graph. So this is the parent graph for every single transformation that we do today. But this is just the basic absolute value of x, okay? We can see it starts at the origin 0, 0. It's got a slope of 1 on each side. So this right side is going up 1 over 1. This left side is going up 1 and left 1, okay? So it's a -1 slope, but it's still a slope of the same. So let's go ahead and just talk about what these different transformations did to our parent graph. So let's start with graph A. We can see that it's no different than the parent graph other than, as far as the equation goes, other than this 2 out front. Okay, and what did that 2 cause this graph to do? Did it shift up? Meaning, did it move up or down physically? Like, did the origin change going up or down? No, it did not. So this was a false. Did it shift down? No, it stayed the exact same place. It's still the origin. Did it shift right or left? No, it did not. Did it compress? Okay, so compress would mean to get smaller. Stretch would mean to get wider. Did this get smaller or wider? Yes, which one? We can see that it did get compressed, okay? This is much narrower than this parent graph was. We can see that it is a wider graph up top than on the bottom, okay? So we said it was not stretched, it was just compressed. Was it flipped? What do we think on that? No, it was not. I guess technically it could have been. It would have been the same, but it was not flipped. So you should have got false on that one. Graph B. What has changed about this equation compared to the parent graph? We can see that it's got a 1/3 out front. Okay, so what did 1/3 cause this graph to do? So hopefully you found it didn't go up, did not go down, did not go right, did not go left. It did stretch though. Didn't compress this time, but it stretched. Okay, so what we will find here, so if a number like 2 is going to make something compress, but a number like 1/3 is going to make it stretch, what number is out here? Isn't that just a 1? Let's think about that. It is. So what do we think that means about this 2 and this 1/3? Just think about it. And then we've got graph C, -4 absolute value of x. What happened to this one? Did it shift up? Like as far as like the origin goes? No. Didn't shift down. Didn't shift at all, really, did it? Still the same point. Did it compress or stretch? What is this angle? Is that narrower or wider than the original? It'd be narrower, right? So it did compress, didn't stretch. Did it flip? Yeah. It did flip. What do you think caused that to flip? Why did that one flip and none of the others flipped? What does it have that none of the others had? Okay, so what we're going to notice is, and you might want to write this down somewhere on that note sheet, okay? If we have an a in front of y to the a of x, if a is equal to 1, it's just got that slope of 1, right? If a is less than 1, what happened? What did it do? It stretched, right? So this is going to be a stretch. What about if a is greater than 1, bigger than 1? It's going to compress, right? Or get smaller. So even though this -4, technically a -4 is smaller than 1, really we're just going to look at this as a 4. So what did the whole number 4, would that cause it to compress or stretch? We saw that it compressed, right? Right here, we got a true. But that negative caused it to do what? Flip, right? So a negative a is going to be a flip. Cool. Okay, and now we have our H shift tab. Okay, so looking at this, my parent graph is still that y equals absolute value of x. It's that exact same image as before. Okay, we can see that it's got that point at 0, 0, a slope of 1, and it's going up to the right, up to the left. Okay, that's what that one looks like. And then we've got our graphs that we're comparing to. So, looking at the first, graph A, we have y equals absolute value of x plus 2. And we notice that the 2 is inside of those absolute value bars, right? Okay, so looking at this, what does that 2 cause this to do? What is different about this graph compared to this one? What changed in graph A? What do you notice? Did it shift up? No. Did it shift down? No. Right? No. What about left? There we go. And then did it compress, stretch, or flip? We see that those would also be false. So the only thing true about this is that it shifted to the left. How much did it shift? If I zoom in there, how much did this shift from that origin? So if we start here, we can see it shifted 1, 2 units. What do you think caused it to shift 2 units? Think it had anything to do with this number 2? I do. But that says x plus 2. Why would it shift to the left 2? Let's try the next one and see what we get here. Okay. So this one is absolute value of x minus 4. So what happened here? Did it shift up? No. Down? No. Right. Yes, it did. Didn't shift left. It didn't change stretch or compress, and then it did not flip upside down either. So the only thing that happened was that it shifted to the right. How many units did it shift to the right? Well, let's count. If we start at the origin, 1, 2, 3, 4 units. I do see a number 4 in here. But I don't get, why is it shifting to the right if it's negative 4? Well, this one was a positive 2 and it shifted to the left. Let's try one more and just see what happens here. Did this one shift up? No. Just change colors. No. Did it shift down? No. Right? No. Left? Yes, it did. Did it compress? Yeah, it did. It compressed. It did not stretch. It did not flip upside down. But it did do two things. It shifted left and it compressed. Okay, so what do we think is causing that? Well, we just talked about the compression has to do with this number out front, right? So that 2, we said if it's bigger than 1, it's gonna shrink, okay? But what about this plus 5 here? Why did that shift it to the left and not the right? So here we're going to notice that this is a pattern, okay? And what the pattern is here is, let's go, what am I doing here? I don't know why that's turning blue. Okay, whatever. We'll just move over here. What we're going to notice is y now equals a, so a is still that same thing, okay? We still have x. And then we have what is called the minus h, okay? So h is just going to be how it shifts on that x-axis, so shifting left or right, okay? And we will talk about what that means. We're going to get into that note sheet here in a second, and we'll fill that out. But just know that this negative h, okay, is going to tell whether it's going left or right. but it's always going to be the opposite of the h. So if it says -4, you're going to go positive 4 units to the right, okay? But if it says -5, then, if it says positive 5, then you're going to go left 5 units, okay? And we'll talk about what that means when we get into some more examples. Okay, next up, we've got our k-shift. Let's see what happens here. So, parent graph, parent equation, all the same. Let's start with our graph A. What's changed about just the equation? Well, looks like we got a +6 out here, right? Nothing else has changed. And let's see what that 6 caused this graph to do. Did it shift up? True. Yes, it did. What about down? No. Right? No. Left? No. Compress? No. Stretch? No. Flip? No. Just made it move up. How many units did we move up? Okay, let's find out. Zoom, zoom, zoom. Count from here. 1, 2, 3, 4, 5, 6. Okay. So we moved up 6 units. Interesting. Let's try B. Hopefully you got a graph that looked just like this. What's different about the equation compared to the parent graph? We've just got this -8, right? This one didn't have anything. Okay. Did this graph shift down? So if we're looking from here to here, did that shift? Sorry, up. Did it shift up? It did not shift up. Did it shift down? Yes, I gave you the answer. Did it do anything else? No. So false, false, false. It did shift down though. How many units did it shift down? We'll notice it shifted down 8, which makes sense because that's a -8. Okay? Then we've got a crazy one over here. -1/3 absolute value of x -4. Okay, so let's first start off. Did it shift up? No, it didn't look like it. What about down? It did, right? This origin is not in the same place. It is downward. How many units did it move down? 4, which makes sense, right? Because I have a -4 out there. So this one makes a lot more sense, right, than that letter H that was the opposite, okay? This one's plain Jane, tells you how it is, okay? Then we've got, did it shift right? No. Left? No. Did it compress? It did something, but did it get wider or did it shrink? So compress means shrunk, stretch means gets wider. Did it compress? I don't think so. I think it got wider, which means it stretched. Did it flip? It did do that too. So this one did 3 different things here. Got a little bit more green on our number sheet than the others did. Okay, and what we're going to talk about here is that, so what we've got here is we've still got our y equals a x, and we still have that -h, which was that x-axis movement, okay? So that is what the h meant. And now we have a plus k at the end. I kind of ran out of room over there. I kind of want to rewrite that. If it will let me. Okay. So y equals a x minus h plus k. Okay. So we're familiar with that k shift now. And now we're going to do some multi-shifts, okay? So nothing new here. We've got the little formula down with all the letters, okay? And we'll talk more about that here in a little bit. But we're going to put it all together now. We're going to see what these different things can do and how, if I'm given 2 graphs, I can tell just by answering these questions what has happened, okay? And even if I don't have the equation, I'm still able to find it. Okay, so we'll start with our parent graph. Same deal. It's the exact same. Now we're going to look at graph A here. So let's move into A. From the parent graph, so from that origin, did we go up? Yes, we did. How many units did we go up? 5, right? Did we go down? No, if we're going up, we're not going down. Did we go right? Yes, we did. How many units? 3. Okay, so from 0 to 3, which was this, what letter? H, right? So the H told us to go right 3. It's a minus 3, so we're doing the opposite, okay? Did it go left? No, it didn't. Did it compress? Looks like it did, right? It did compress. Did it stretch? No. Did it flip? No. Okay. Next one. Same deal. Let's fill this one in a little bit faster. So, moving right along. Did we go up? No. Did we go down? Yes. How many units? Down 4, because this was a negative 4. Did we go right? Yes, we did. How many units? 5, because this was a negative 5. That means to go right. Did we go left? Obviously not. Did we compress or stretch? We did compress. Why did we compress? Because it's a bigger whole number. Just the number again. Don't look at the sign out front. But the number is bigger than 1, just like this one was, which tells us to compress. Did we flip? Yep, we did. That's what the sign tells us to do. So if the negative's out there, we're flipping. Okay? Last one, 2/3. Hold on, I gotta zoom out so I can see my questions. Did we go up? No. Did we go down? Yes, we did. How many units? 7. Okay, this graph is just spaced out a little different. Each of these units means 2 instead of 1, because we can see that there are 5 lines between the 0 and the 10. Okay, did we shift right? No, but we did go left, and we went left 5, right, because this is a positive 5. Did we compress or stretch? Well, I can tell just by looking at that 2/3. We are stretching because that's bigger, okay? And I can also tell by looking at the graph because it's bigger. And then did we flip? Nope, because that 2/3 is not negative and it's not flipped upside down. Okay? So that is how we do our different transformations. So now whenever I give you this formula, it's not going to be that hard because we just learned it. Alright, go ahead and get out those note sheets. We're going to start off with question 1. What is the parent function of an absolute equation? Absolute value equation. We know that because that was on our document that we just did. It was on every single page. So y equals absolute value of x. Number 2, we're going to skip. This is actually going to be your warm-up next class, so don't lose this sheet, but we'll come back to it. Okay, now we're just going to fill in our vertex form. So that formula that we discovered is what we call vertex form. So what it is, it's y equals a absolute value of x minus h plus k. What the vertex is. So we know that parent function, it just had a vertex of 0, 0, okay? But not all of them had that. A lot of them shifted, flipped. We performed all these transformations. So the vertex is going to change places, and where it ends up is going to be your negative h, k value. So that's just a coordinate point. The x is the opposite of whatever h is, so negative h. And the y is k. Plus k, it's already positive, okay? So it just stays whatever sign it is. If it says minus 5, it's a minus 5. If it says plus 2, it's a plus 2, okay? Then we have our a value that we have not addressed yet. So that is our slope. So if you noticed how the parent function just had a slope of 1, we kind of talked about that. The slope on the right side was positive, and then the slope on the left side was the exact same slope, but it was just negative. So it was a negative 1, okay? And we'll talk about that when we get into some examples. So let's go ahead and start on 1. So the first thing I've got to do is I've got to find where the vertex is. So again, vertex is this negative hk. Vertex form, find that negative hk from this equation. And so that's what we're going to do. So we're going to write the vertex first. So we've got negative h, comma, k. So h right now is negative 2. I need the opposite of negative 2 because it's negative h. So it's going to be 2. And then k is going to stay whatever sign it is. So negative 4. So my vertex is 2, negative 4. So I'm going to plot that point. Okay? What's my slope? I don't have an a value, right? Just like my parent function didn't have one. What was its slope? Didn't we just have an imaginary 1 out here? Yeah. So I'm going to go up 1 over 1. Hold on a second. There we go. Up 1 over 1, up 1 over 1. Keep going. Opposite of that would be to go up 1 and left 1. And I'm going to keep going all the way up off the graph. You only need a couple points. To draw straight lines pretty well. Okay, so it's going to look something like that. We know those lines keep going on and on for forever. But this is as far as they will go off my graph. Okay, now what it asks for is this D and R. What these stand for are domain and range. This is a super important part of today's lesson that we have not talked about. So domain, and write this down at the bottom of your sheet or somewhere. Domain is all your x's. So all the way across the x-axis, it just wants to know where do your x's start and where do they end. And then range is the same thing, but it's going to be all of your y's. So looking at your y-axis, where does it start and where does it end as far as where things are defined. So if we look, for our domain, which is our x-axis, where is it defined from left to right? Well, we just said that these lines go on all the way left and all the way right to infinity. So that's literally what our domain is. And with these absolute value functions, hint, hint, your domain is actually always going to be that. It is always going to be negative to infinity with absolute value functions. With some of the other functions that we get into later, that's not the case. But with absolute value, no matter what I have, even if I have something going down, I'm going to have two lines going left and right to infinity, so domain is always going to be that. Then we've got the R, which is our range. It's our y values. So looking at our y-axis, where do our values start and where do they end? So if I look, hopefully you agree with me, my y's start right down here. So looking from the bottom to the top, they start at -4 on my y-axis. So that's where they start. And then looking at where they go up, well, they're going to infinity. They're not ending. Okay? So again, looking at from the bottom to the top for y's and for the x's from left to right. Okay? Let's try number 2. So we've got 3 absolute value of x plus 5. Let's first find our vertex. It's the easiest part. So it's -hk. Well, I right now have an h of 5, so a -5 is going to be my h. I don't have a k. What's the number when we don't have something? 0. So to plot this, I'm going to go to the left, 1, 2, 3, 4, 5, and it's going to be on that axis. Okay, and then my slope. What is my a value? It is 3, which is the same thing as 3 over 1. So up 3, right 1. Up 3, right 1. Up 3, left 1. Up 3, left 1. These lines are just going to mirror each other. We know that when that number is bigger than 1, it should compress, right? And it did do that, so that's a good sign. Our domain. So for our x values, we said with all of these absolute values, reading from left to right, this is going to go on to infinity forever and ever and ever. This is also going to do the same to the right. Okay? So our domain is -infinity to infinity. And then reading from bottom to top, it's starting at on my y-axis, 0, and going to infinity. Okay. We then have a few more. Don't worry about these bottom ones right now. But we're just going to look at these top ones. We're just going to briefly talk about them because we don't have a lot of time, and I want you to have a little bit of time to zoom and do your homework. So let's skip down to number 6. Let's do number 6. This is similar to one of the ones that we did on the Pages doc. So first off, I want to find my vertex. Do I have an H here? I don't have anything written in that absolute value next to that x. So my x is just going to be 0. And then my k is going to be 7, right? Because I've got the 7 written out here. So plot that point, 0, 7. And then my slope is -3/4. So down 3, right 4, down 3, right 4. The opposite is down 3, left 4, down 3, left 4. Draw the line. Okay. Reading from left to right, -infinity to infinity. Going on and forever from left to right. And then our range, reading from bottom to top. Well, we said it's going on and on forever to infinity, going down, right? So reading from bottom to top, we're reading from -infinity to right here. This is where it ends on the top. So that was 7, we said. So -infinity to 7 is going to be your range on that one. Okay, so that is number 6. We don't have a ton of time to do another one, but I think you should get the gist on these because we did a lot of them. You can use Desmos to check your answers, but make sure you know how to graph these without using that. Okay? Cool. I will be on Zoom at the time listed on Canvas, and then your homework is just your homework problems, and then when you feel confident, do the homework check. Good deal? Let me know if you have questions. Thanks, guys. Bye.